This is SpaceTime, Series 26, Episode 19. Coming up on SpaceTime, the distant galaxy that mirrors the early Milky Way, 12 new moons discovered orbiting around Jupiter, and what caused the Virgin Orbit Cornwall failure. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a distant galaxy that's showing them what our own galaxy, the Milky Way, might have looked like early in its history. The ancient galaxy has been named the Sparkler because it's embedded in a system of dozens of brightly glowing globular star clusters. Globular clusters are tightly bound ancient stellar spheres, often containing thousands to millions of stars, all tightly bound together by gravity. They're much older than the less dense open star clusters, which are found in the disks of galaxies. Many globular clusters are composed of stars which were all originally formed at the same time in the same molecular gas and dust cloud. But others appear to be the surviving cause of ancient galaxies that have been cannibalized by other galaxies through galactic mergers. Globular clusters are commonly found in the halo of galaxies. Our own galaxy, the Milky Way, has at least 150 globular clusters, possibly more than 200. And we know our nearest big neighbouring galaxy, Andromeda, has at least 500 globular clusters. The new observations, which were made by NASA's James Webb Space Telescope, suggest that the sparkler is cannibalizing globular clusters as it grows, a process which can still be seen today in our own Milky Way as it consumes satellite galaxies around it. The findings, reported in the monthly notices of the Royal Astronomical Society, suggest the sparkler is at least 9 billion light-years away in the southern constellation of Violans, the flying fish. The study's lead author, Professor Duncan Forbes from Swinburne University, says the findings mean that we're seeing the galaxy at a time when the universe was just over 4 billion years old. And Forbes says it's providing a unique insight into the formation not just of the sparkler, but also of our own galaxy, the Milky Way, in its infancy. The observations were only made possible because the sparkler is being gravitationally lensed by a foreground galaxy, which is literally bending and amplifying the sparkler's light. Forbes, together with his co-author, Professor Aaron Romanowski from San Jose University, examined the age and metallicity distribution of a dozen of the compact star clusters surrounding the sparkler and determined that they resemble younger versions of the clusters found around the Milky Way. Astronomers refer to all elements other than hydrogen and helium as metals, as they're produced during the lives and deaths of stars. And so, as stars live and die, and consequently distribute more material into the universe for future generations of stars to absorb, stellar metallicity increases depending on the age of the material in which the star was formed. The authors found that several star clusters in the sparkler have very old formation ages and are metal-rich, similar to those seen in the bulge of the Milky Way galaxy, and so they're likely to be globular clusters. But a couple of star clusters had intermediate ages and were metal-poor. These star clusters are associated with satellite galaxies that are being accreted onto the sparkler. The sparkler appears to be swallowing up satellite galaxies and their systems of globular clusters, just as the Milky Way has done in the past and continues to do today. Although the sparkler is currently only 3% the mass of the Milky Way, it's expected to grow over cosmic time, eventually matching the Milky Way's mass and size in the present-day universe. Forbes says the team will need deeper imaging of the sparkler in order to detect more clusters and satellite galaxies around it. He says we appear to be witnessing firsthand the assembly of a galaxy as it builds up its mass.
The sparkle galaxy was named because it has sparkles around it, and those sparkles are star clusters that we think many of them are globular clusters. And the reason that we were able to see these globular clusters in this very distant galaxy was because of two effects. Well, one, first of all, using a brand new telescope, the James Webb Space Telescope, but also the fact that the brightness of these objects was magnified due to gravitational lensing, so they appeared behind a nearby cluster of galaxies, and their brightness was enhanced by this effect called gravitational lensing.
And so as you looked at this gravitationally lensed distant galaxy, some 9 billion light years away, you saw all these little, what looked like globular clusters in some cases orbiting. That must have been interesting, because that must give you all sorts of insights into what the early evolution of galaxies is all about.
Yes, that's right. It was very exciting. So basically, this is the first time globular clusters been seen in such a distant galaxy. So it's at a redshift of 1.4, and as you say, that's equivalent to what we call a look-back time of 9 billion years, or in other words, 4 billion years after the Big Bang. So we're looking at these globular clusters as they were 9 billion years ago. So it gives us great insight into the globular clusters that surround our Milky Way galaxy. So we have about 200 globular clusters around the Milky Way galaxy. They're all very old, very ancient. They formed a long time ago, but it would be, you just get a sort of a snapshot of what it is today. You can think of a telescope, if you like, as a time machine. And so as we look back in redshift, we're looking back in time. So we actually have managed to find some details of these globular clusters that surround this galaxy 9 billion years ago. So it's like looking at the globular clusters when they were in their infancy.
So what did you actually see? Was it like a swirling mass of stars with little clumps falling into the swirl? Is that the sort of thing that you were looking at?
Yeah, images were taken in different filters or different bands. And so you can see the sparkler galaxy itself, and then you can see a dozen or maybe even 24 of these bright little star clusters around it. And from the images that were taken in different bands, it's possible to calculate or estimate the age and the chemical composition of these star clusters. And so it's by looking at their ages and chemical compositions that we were able to sort of match them to analogues in the Milky Way today. So we found some star clusters that had literally just formed in this galaxy, but also some, interestingly, that were about 4 billion years old, which essentially puts them at the age of the universe. So they formed 13 billion years ago, from our point of view, which is exactly the same as what we see for what we infer for globular clusters around the Milky Way, that they also formed 13 billion years ago, just after the Big Bang. So that's what makes it really interesting.
And so what do you think these globular clusters are? Were they collapsed molecular gas and dust clouds, or were they the centers of galaxies, or are we looking at a mixture between the two?
Yeah, there is still some debate on exactly how globular clusters form, but they no doubt formed from molecular clouds in some ways, probably under very high pressure. And that cloud eventually, that provided the fuel for lots of stars. And so a globular cluster today is this very dense spherical distribution of around 1 million stars, maybe 100,000 stars, and that sort of size.
This is giving you an insight into what the Milky Way may have been like at that time period.
Yes, that's right. So the mass of the sparkler galaxy that's hosting these globular clusters is only about 3 or 5% of the mass of the Milky Way today, but galaxies grow with time. And so the sparkler galaxy at redshift 1.4 will actually grow by many factors by the time it reaches redshift 0, equivalent over the 9 billion years of cosmic time. And it will essentially grow to be about the same size as the Milky Way. So in that sense, this really is looking at like a Milky Way in its infancy, with its collection of globular clusters just starting to form around it. It is a galaxy that we expect, the sparkler galaxy, we expect it to be a giant galaxy of a similar mass to the Milky Way after 9 billion years of cosmic evolution.
So score one there for galactic cannibalism as galaxies grow, I guess.
Well, indeed, exactly. That's exactly right. So that is how galaxies grow. They accrete matter, and they accrete smaller galaxies. And there's certainly evidence in the Milky Way that the Milky Way galaxy has grown by accreting small dwarf galaxies, at least half a dozen of them. And interestingly, again, when we look at the sparkler galaxy, there's a hint that a couple of those globular clusters might be coming in from an even smaller dwarf galaxy that's being accreted that we see in the images from the James Webb Space Telescope. So again, another connection to the way the Milky Way formed, another example of it being an analog at earlier time.
It sounds like there's a lot happening in the sparkler, but the one thing you haven't mentioned is any evidence of anything happening near the center of that galaxy. When we think about early galaxies, we also think about very active galactic nuclei at their center. There are hungry black holes there that are eating a lot of gas and dust that's getting too close. Is that the sort of thing one would expect to see in a galaxy like the sparkler? And Was there any evidence of that there?
Certainly, if the sparkler turns out to have a mass like the Milky Way galaxy after cosmic evolution, then we would expect it to host a supermassive black hole, just like the Milky Way does as its centre.
That's Professor Duncan Forbes from Swinburne University. And this is Space Time. Still to come, 12 new moons discovered orbiting around Jupiter, and first clues as to what caused Virgin Orbit's Cornwall disaster. All that and more still to come on Space Time. Astronomers have discovered 12 new moons orbiting around Jupiter, bringing the solar system's largest planet's total tally to 92. The new Jovian moons were discovered using telescopes both in Hawaii and Chile in 2021 and 2022, and their orbits were then confirmed through follow-up observations. The moons range in size from 1 to 3 kilometres and have been formally added to the records of the International Astronomical Union's Minor Planet Centre. The discovery comes at a time when the European Space Agency is making its final preparations to launch its JUICE mission. JUICE will launch to study the Jovian ice moons in April. Meanwhile, NASA is also planning a new mission to Jupiter, Europa Clipper, which will launch next year on a mission to explore the ice moon Europa, which is thought to contain a large subsurface global ocean. The new Jovian moon discoveries takes the crown for the most moons away from Saturn, which so far has 83 known moons, 20 of which are still waiting confirmation. But those numbers could change any day as more and more moons are discovered orbiting the two gas giants. Both Jupiter and Saturn have lots of small moons, many believed to be fragments of once bigger moons that collided with one another or with comets or asteroids. And of course the ring systems of both these worlds are also remnants of long-gone moons. For the record, Uranus has 27 confirmed moons, Neptune 14, Mars has 2, the Earth has 1, while only Venus and Mercury remain moonless. This is Space Time. Still to come, what caused Virgin Orbit's Cornwall failure, and later in the science report, the ChatGPT artificial intelligence passes its law school exams, and only just missed out on passing its medical exams as well. All that and more still to come on Space Time. Early indications suggest last month's multi-million-dollar failure of Virgin Orbit's Launcher 1 mission from Cornwall was caused by a $100 filter on the Stage 2 engine, which somehow came loose and dislodged. Reports from the investigation being undertaken by Virgin Orbit and the UK Space Agency suggested the filter was clearly there when the rocket was assembled, but no longer present as the second stage engine lit up. Somehow it fell off. The maiden Cornwall drop launch aboard Virgin Orbit's Boeing 747 airliner Cosmic Girl was meant to carry 9 satellites into low Earth orbit. After taking off from the Cornwall Spaceport runway, Cosmic Girl climbed to 35,000 feet over the Atlantic Ocean just south of Ireland before drop launching the Launcher 1 rocket from a carrier pylon next to the fuselage under its port wing. The first stage of the 21-metre-long Launcher 1 rocket ignited seconds later and performed nominally, quickly accelerating the rocket towards space. However, the problems began following main engine cutoff, stage separation, and second stage ignition. The rocket and its multi-million-dollar payload began plummeting back to Earth, most of it burning up in the atmosphere during re-entry. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that over 40% of all land vertebrate species may be subjected to extreme heat events by the end of the century if humans don't curb global emissions. The findings, reported in the journal Nature, show that at least 41% of species will experience extreme heat events across at least half of their land distribution under a high emissions scenario in which planetary warming could reach 4.4 degrees Celsius above pre-industrial levels. Amphibians and reptiles are likely to be at greatest risk, with 55.5% of amphibians and 51% of reptiles expected to experience extreme heat events under high emission scenarios, compared to 25.8% of birds and 31.1% of mammals. The authors say curbing greenhouse gas emissions would substantially reduce the effects of extreme heat on biodiversity. Scientists have developed a new prostate cancer blood test with a 94% accuracy rate. A report in the journal Cancer claims the new prostate screening epi-switch or PSE blood test is more accurate than the currently used prostate-specific antigen or PSA blood test. Prostate cancer remains the most common type of cancer found in men. But only a quarter of men who have a prostate biopsy following an elevated PSA level are found to have prostate cancer. Researchers tested the new PSE test, which combines the traditional PSA test with an epigenetic epi-switch test in a pilot study involving 147 patients. They compared its results to those of the standard PSA test and found that the PSE test significantly enhances overall detection accuracy for at-risk men. A chatbot powered by reams of data from the internet has passed its law school exams in the United States after writing essays on topics ranging from constitutional law to taxation. ChatGPT from OpenAI, a US company that's just received a massive injection of cash from Microsoft, uses artificial intelligence to generate streams of text from simple prompts. The results have been so good that educators have warned that it could lead to widespread cheating and even signal the end of traditional classroom teaching methods. Jonathan Choi, a professor at Minnesota University Law School, gave ChatGPT the same test faced by students, consisting of 95 multiple-choice questions and 12 essays. The bot scored an overall C+. That's enough for a pass. But it was still near the bottom of the class for most subjects. Apparently, it bombed badly in multiple-choice questions involving mathematics. Meanwhile, a separate study, reported in the journal PLOS Digital Health, claims that ChatGPT almost passed the United States medical licensing exam. The AI software was able to score at or close to the 60% passing grade needed for the notoriously difficult series of 3 exams that are required to get a medical license in the United States, which covers most medical disciplines. The AI scored between 52.4% and 75% across the 3 exams, providing what were described as coherent and frequently contained insights. The past few weeks have seen a spate of so-called stunning new images of UFOs. While the sharp ones might well turn out to be Chinese spy balloons, most are so shaky and blurry it's hard to really tell what they are. Sadly, no specific sightings provided the proverbial smoking gun needed to prove that we are not alone in the universe. But the wide array of videos and photos of odd aerial anomalies have kept skeptics amused. Tim Mendham from Australian Skeptics, who gets a lot of these images across his desk, wants to know why none of these people have ever heard of a tripod.
From my position here, at the front line of skepticism in Australia, I get film and photos of UFOs every day, as I do get for ghosts and as I do get for unknown animals and all sorts of things. So I get them all the time. Most of them are rubbish. Either so vague or out of focus or shaky or whatever, you really can't see anything. Some amorphous blobs suddenly become evidence of Bigfoot. Others are obvious fakes, and there's a lot of those around, especially these days. You can manipulate imagery on your phone and actually probably put out pretty convincing photos of things that don't exist. Fake photos is getting very common. So the evidence being put forward by UFOs, there's one article talked about stunning evidence, another talked about the classics of 2022. They're really, most of them are either quickly identifiable, like they're not unidentified, they're quickly identifiable. They're too vague to even get an idea of what they might be, and therefore they probably stay unidentified. But an unidentified blob on a photo does not instantly say UFO. It could be Venus, it could be clouds, it could be a whole lot of different things.
It's amazing how many times I get images sent to me or emailed to me, and it turns out, depending on what part of the country you're in, it's either Venus or it's the twin exhausts of a fighter jet that's accelerating away from the person with the camera's viewpoint, or something like that, something that can be really easily explained.
Yeah, there was one we did a while ago. I remember sort of someone phoned up and said, I definitely saw a UFO in the sky. It was near the moon. You think, okay, it's not the moon? No, it was near the moon. Okay, what direction were you looking? What time of day? What time of night? Etc. And they pinpointed, okay, at that point in the sky, Jupiter, I think it was very bright. Did you see Jupiter? No. Well, you would have seen Jupiter because it was very bright alongside the moon. And so therefore, you would have had three things, a UFO, a Jupiter, and a moon. And the person said, no, he saw two. Well, they say, you probably saw Jupiter. But it happens all the time that people don't do a lot of research. The interesting thing about these programs that talk about the best sightings or the strangest sightings, whatever, often the program itself is better produced than the evidence. Sometimes it's overly produced and it made it look like an intimate chat with someone when it's so obviously just filmed in a studio. And then they put forward the evidence and then you get the shaky, vague, out of focus camera work. And they
how does that work these days? I mean, most people have a phone with a camera on it, and these things have their automatic devices for steadying the thing so it doesn't look shaky and out of focus, and they still manage to do that. They must be doing it deliberately to make it look like a squash blob or something.
That does happen a lot, the deliberate sort of camera shake and that sort of thing. It's happened, for donkey's years, it's been happening that way. But yeah, I mean, we get people who send in videos taken on their phone and say, why don't you lean against something and hold, or put the camera against something and hold it still, right? Now what they do is they look at something, they zoom into the extreme zoom, and then the camera is just shaking and the thing goes in and out of frame all the time. You think, no, you can zoom later. Film it steady, right? And lean against something, lean against a fence post or a brick wall or a tree or something, whatever you're near, and film it steady, and then we can look at it. But no, you get all this evidence, which is really terrible. I just think people are not very good at filming things, quite frankly. But as you say, cameras these days can compensate for shake to a certain extent. If the person is shaking around, they're not very good photographers. They don't normally shoot things, photograph things in the sky, especially something that might be moving, and they're moving, and the camera's moving, etc. No, you say just stand still. You can zoom out, you can film it, and then you can zoom in later on the image. But no, they don't do that. So evidence put forward, even the best evidence put forward, most of it is terrible. I remember seeing one particular article recently on the best of 2022, and basically everything they explain as to what it actually is. Often balloons. Balloons pop up quite a lot. I don't know how many balloons there are in the sky, but apparently a lot of people filming these things are filming balloons. But as you say, Venus, cloud formations, planes, all that sort of stuff can be explanations for a lot of these things. And if you can't explain it, you have to leave it as unidentified, not as a flying object. It's just unidentified and you don't know, which is what the
But what happens when you get lots and lots and lots of these unidentified things? That's still not proof of something being there. It's just that you've got lots and lots of really bad evidence of unidentified things.
That's right, exactly right. If someone submits a bit of evidence, you say, well, that's a 2 out of 10. That's not very good. Let's get another bit of evidence, and that's another 2 out of 10. Here's our third bit. Oh, that's another 2 out of 10. It's not very good. You don't add them together and get a 10 out of 10. You just got a lot of 2 out of 10s, and that's the issue. If everything is a 2 out of 10, you start wondering, will there ever be a good one, or does it even exist? And if all the evidence is bad, that probably indicates that it's a not real phenomenon, or certainly unidentifiable anyway. So a lot of bad evidence doesn't make good evidence.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.